Hello, so here's the problem number 1 of graph assignment, and in this assignment we have to determine if there is a path between two edges of a graph. So for example, this 2 is a starting source edge and this one is a endpoint, and we have to determine if there is a path from 2 to 1. So for example, in our case we'll check first of all if there is a path from 2 to 0 and then from 0 to 1. So how are we gonna do this? First of all, let's just briefly go through that. Graph will be given us as a list of all edges in a graph. They will be listed accordingly like 0, 1, 2, 3, and this list will consist of list to which edges each edge has the connection. For example, it will be saying that from 0 edge we have connections to 1 and 2, like 0, 1 and 2. So from 1 we don't have any path, as you see from here. From 2 we have paths to 0 and to 3, and 3 will be also defined as a null because it doesn't have any path to any edges in the graph. So to solve this problem we will use a queue data structure. We will just storing each edge from the list and trying to find out if we can go from that point to another and check if at the end we will be able to get to the final destination endpoint in the graph. And also, in order to avoid double checking of each edge in the list, we will be using the Boolean array, which will be the size of the list. So right now is the list of a graph will be 4, that's why the array also will be equal to 4 and will be filled by default with the false values. So once we will visit, we'll take into consideration one of the edges in the list. We'll just checking it by changing the value to the true. So let's start to write our code, not our code but the logic how we will trying to find out the path between two edges. So starting from 2, we'll just store this 2 in our queue. Then from that point we'll just initialize our while loop, which will be run it until our queue will not be empty. At this point in the while loop we'll just declare another variable vertex which will be fulfilled by the value from the queue. So from queue we'll pop this value and we'll push it to vertex, and then we'll just check if vertex is equal to endpoint, which is 1. Once it will be equal to endpoint, we will just return true. Otherwise we'll go continue to run our while loop. At this point we also change our value in our array to true, meaning that we already considering this edge in our while loop, and that's why we're turning it to true. From that point we'll just go through all connections that our 2 does have. So we'll just take all these elements and push it to queue, and accordingly we will just change the values in our array to true. So meaning that we this will mean that we are not going to again push to our queue this 0 and 3. We will just push to this queue just edges that are have not been considered before. That's why we're just changing it to true. So 0 and since vertex is not equal to 0, then we will push another data from Q, which is 0, and check if it's equal to 1 or not. Also, we will see that 0 has another connections like 1 and 2. At this point, we'll check which connections we have not considered yet. True, 2 is already considered. It has a true value. We're not considered 1. That's why we're just turning it to 1 and also push this 1 to our queue. After that, we push this 3 to our vertex and check if it's equal to 1. Since it's not equal to 1 and already we considered this variable and checked if it's equal to our destination endpoint, that's why we're not gonna check the what connection it has. So that's why the next variable, that element that will be tried to consider will be 1. So from here we'll just pop and push it to vertex and check if it's equal to 1. At this point we will see that it's equal to 1. That's why we will just return true. Otherwise, if we will not be able to find out this connection, we will just return false. So let's check how our code will look like. So this is like the definition of graph class and a class H. So class H is basically just the class for defining that connections between two edges. For example, it just storing the connection, like the list of connections, like from 2 to 0, from 0 to 1, etc. And the graph is just basically is a list of edge connections. So at the beginning it's just declaring adjacency list, list which consists of lists, and into that list first of all we're just adding the new list according to the number of edges. In our case it's like 1, so we have 1, 2, 3, 4 edges. Then we're just fulfilling our list with the which edge has path to the list of connections between edges, like 0 has connections to 2 and 1. So 0 is a source and 2 and 1 is a destination points. 1 is source and it doesn't have connection to destination point, so etc. So this is basically the definition of a graph class. And our code for finding to find out the path will be as follow. It will be called as isConnected. The input parameters will be graph itself, integer source and integer destination. So here at the beginning we will just declare array. The size of array will be graph adjacency list size. Then we will just declare queue. And we'll change the value of our first source edge as a true, meaning that we already considered this edge in our case. Then we'll push it to our queue, and then we will just initialize our while loop. And our while loop will be run until our queue will not be empty. So there will be a variable for vertex. A variable will be fulfilled with the element from queue. And at each time when we will store any data to our vertex, we'll just check if it's equal to our destination element. If it's equal, we'll just return true. If it's not, we'll just initialize for each loop with the, where we'll just go to the list of a graph and check which connections this vertex has in a graph. So in our case it will be graph adjacency list at vertex index, and we will check if we consider this edge before or not. So in our case we will check if discovered is false, if our discovered array is false at u. So we just change this discovered to true, and we also push this element to our queue. At the end, if we will not be able to find out any the equation with the endpoint, we'll just return false.